Hey there, my name is Swetha and today I'll be sharing my 2-degree freedom IMU-controlled arm. Here's a video of the arm in motion. I'm holding an MPU-6050 6-axis gyroscope and accelerometer. To recalibrate the zero position of the sensor, I press the reset button on the Arduino. In the background, you can see processing code in action. The yaw and pitch are displayed on a gauge and the angles are printed. The arm is made up of two 180-degree microservos with 3D printed mounts. Here's a summary of the system. First, sensing. The MPU-6050 IMU is a 6-axis accelerometer and gyroscope. For this project, I made use of its gyroscopic function. The sensor uses I2C communication. Next, logic. The sensor communicates with an Arduino Uno, which calculates yaw and pitch angles and maps these to PWM duty cycles. The Arduino writes PWM signals to two microservos, and that leads us to actuation. Two microservos, one for yaw and one for pitch, are controlled with the Arduino PWM and powered with a separate set of batteries. As mentioned, the servo motors are powered with an external battery. The Arduino also prints the yaw and pitch angles, which are taken in by a processing script. This script parses the message and plots points on a gauge. Here's a clip of the position monitor updating as the sensor is moved. Here's a simple wiring diagram. The MPU-6050 uses the SDA and SCL pins on the Arduino for I2C communication. The Arduino outputs PWM signals to the yaw and pitch servos, which are powered by a 4.5-volt battery. And now a little bit more about the Arduino code. The code reads the MPU's angular velocity values and multiplies by a time step to find the current angle. I use the wire.h and MPU-6050 libraries to enable I2C communication and easily read the correct registers on the MPU-6050. Electronicwings.com was a really helpful resource here, which I linked. I printed the angles to communicate with processing. Then I mapped the angles to duty cycles for the yaw and pitch servos. Using those duty cycles, I used a custom PWM function using while loops and the micros function. The servo mounts were modeled in Fusion 360 and printed on a bamboo printer.